If the screen is visible to you, Shedge, just confirm once.
Yes, sir.
Okay. So next assignment that we'll see, that is configuration of OSPF using packet tracer. In the morning session, we have seen configuration of EIGRP. Now we'll see configuration of OSPF using packet tracer. I have made one Word file for it explaining the things, steps, and all the things, right? That is helpful for your file preparation also. So OSPF stands for Open Shortest Path First. And it is a routing protocol for IP networks. It uses a link state routing algorithm, and falls into group of interior gateway protocols, IGPs, and they are also operating within a single autonomous system. Then OSPF gathers link state information from available routers and constructs a topology map of the network. How many links are coming to the router, the link state information, or that all the information is stored in the topology map. The topology is presented as a routing table to the internet layer for routing packets by their destination IP addresses. Then OSPF is an interior gateway routing protocol for routing IP packets, and OSPF detects changes in the topology such as link failures they are detecting, in convergence on a new loop free routing structure within a second. Main of OSPF is it computes the shortest path tree for each route using a method based on Dijkstra's algorithm, right? So shortest path is calculated using Dijkstra's algorithm in OSPF. Then OSPF routing policies for constructing a route table are governed by link metrics associated with each routing interface, and for which link say cost factors are so there. Cost factors may be the distance of router, data throughput of a link, or link availability and reliability, expressed as simple unitless numbers, right? This also provides a dynamic process of traffic load balancing between route of equal cost. OSPF divides the network into one more areas. That means that OSPF, there's one more concept associated with OSPF, that is areas. So OSPF divides the network into routing areas to simplify administration and optimize the traffic and resource utilization. That means suppose there are 100 routers are there. Those routers are grouped into different areas, right? So 3-4 areas for optimizing the traffic, right? Out of these, whatever the areas available, one area is treated as the backbone area, and there are certain routers which are placed on the boundaries of different areas. They are called as the area border routers, ABRs. So ABR maintains separate link state database for each area it serves and maintains summarized routes for all areas in the network. Then few OSPF characteristics we'll see here. Now these OSPF characteristics are like OSPF stands for Open Shortest Path First. It's standard protocol. It is a link state protocol. It uses shortest path first Dijkstra's algorithm to find out the best route. Here, one important point that you need to notice that it supports unlimited hop count. Now, if we compare it with the EIGRP routing protocol, in EIGRP, it supports by default 100 hop count, and up to max 255 it can support, right? But here it will support unlimited hop count. This point, distinguishing point of OSPF from EIGRP, you should keep in your mind. Then metric cost calculation is there for finding the best route. So cost is find out as cost is equal to 10 to the power 8 divided by the bandwidth. Administrative distance is 110, right? Administrative distance is here 110. What is administrative distance? The distance that already we know what do you mean by administrative distance. See, administrative distance like it's administrative distance or route reference is a number or arbitrary unit assigned to dynamic routes, static routes, and directly connected routes. Now the value used in routers to rank routes from most preferred. That means the route is having low administrative value will be treated as the most preferred, and the route which is having highest administrative value is considered as the least preferred route. Right. So administrative distance, that is AD, is used to rate the trustworthiness of routing information received from the neighbor router. Right. The route, as I told, the list AD will be selected as the base route to reach to the destination remote network, and that particular route will be placed in the routing table. Now the range of administrator distance is 0 to 255. Now for RIP, routing information protocol, that already we are studying the assignment number 1A, the default value of AD for RIP is 120. Then for EIGRP, the default value is 90, and for this OSPF, the default value is 110, right? Keep in mind. Then it is a classless routing protocol. Then it supports only equal cost load balancing. We have already explained what is classless routing protocol, cost load balancing. Then introduces the concept of areas to edge management and control the traffic. Then again, important feature here, updates are sent through anticast address to 24.0.0.5. Right, whatever the hello message exchange is there, suppose first router send the hello message to the second, that is I am this and this, who is there on the other side, so that message is sent as a multicast, right, on multicast route. So and the whatever the reply that comes on the unicast, it's faster conversion supports. Then here important point that you should notice, it sends hello packets every after 10 seconds, right? About two routers are there, router A and router B. Router A sends hello packet to B after every 10 seconds. Now, if for next suppose router A sends message to router B, and for next suppose 40 seconds the router B is not responding to A, then router A will treat as the neighbor link is goes down until it will remove that neighbor list or neighbor entry from that particular neighbor list table of its neighbor list tables, right? And as compared to EIGRP, in EIGRP, hello packets are sent every up to 5 seconds, and after if it they will not get response after 15 seconds, it will be treated as dead. But here in OSPF, sends hello packets every 10 seconds and will be treated dead after 40 seconds if you are not getting the reply. It also gets gives the incremental update. That means whenever update is there, it will update the neighboring tables, right, from that particular point onwards. Then OSPF basic configuration process, right? So I will write for you more clarification. It's a configuration. OSPF basic configuration process. Now this entire OSPF process goes from 7 stages. These stages are like down stage, initialization state, two-way state, X-star state, exchange state, loading state, and the full state. Now let's understand one by one with respect to this scenario, or say two routers is there. This is the scenario, router A and router B on interface E0 and E1 accordingly. Router A is having address 170.16.5.1/24. That means सबनेट मार्क्स 255.255.255.0. दैट 24 का मीनिंग ये होता है कि आपके जो 24 बिट्स एक्टिव होते हैं, राइट, दैट मीन्स 255.255.1111111 होते हैं, राइट. देन लास्ट का 00 होता है. देन राउटर बी इज हैविंग द एड्रेस 172.60.5.2. got. Now in the down state, what will happen? Router A and router B does not know anything about each other. That is the down state. Next state is the init state, initialization state. Next state is the initialization state. So in the initialization state, router A will send hello message to router B on multicast address like 244.0.0.5. So router A sends, I am router ID, say 192.60.5.1. That means this router. I am a router ID with this, and I see no one. It send this message to say B, right? Then if B is in direct connection with A, then router B neighbor list, it will add that 5.1 there and say on interface E1, right? It will add that. Then router B will respond to router A, that is a unicast. It will unicast to A that I am a router ID with 170.116.5.2. That means this router, right? And I see U, that means I see 170.16.5.1, that I can see the router A, right? So here after this hello message, the router A now confirm that router B is its neighbor, so it adds his 5.2 in his neighbor table, correct? That means it will now start the process of adding that particular IP in the neighbor table. Now this, first of all, this after this particular initialization state, that means it will initialize the hello communication between the hello message sent, reply comes, again it will send hello message and reply comes. That is the two initialization. In the two-way state, both the router updates their neighboring tables. That means router A is have updated neighboring list having B's entry, and B updated its neighbor list having A's entry in it. That is the two-way state. The next state is the E0 state. Next state is the X start state. Right now, in the X start state, before we go to this particular X start state, we should understand the concept of router ID. Right? So we'll first of all, I will explain you the concept of router ID. Then we'll move ahead. Right now, here I explain down state initial two-way state to you. In the two-way state, you can have SHIP OSPF neighbor. This command to check the neighbor list. Now, before we move to the X start state, we should understand the concept of router ID. What is router ID? Generally, say for example, if this is the scenario in front of you, this is the router, three physical address are there and one logical, right? This red is the logical address, logical interface, for example, and having some address, loopback address, for example, if it is having. Now, generally, what happens if anyone wants to communicate with this router from this left side, right? Suppose there is a router B here, or say router D here, or wants to communicate with this particular router. Then in that particular case, now just a minute, I will explain to you. Now, if there is some router, no problem. If there is a router towards this left side and that particular router D wants to communicate with this router, right? Then this particular router to the left will identify this particular router with this particular IP address. If there is communication from right side, that particular network will address this router with this address. If there is communication from interface E0, it will identify that router with this address, right? And for logical loopback addresses, if there is any network, it will identify with this address. But in case of this OSPF, there is a concept of router ID used. If the router ID means the highest IP address of the active physical interface of the router is the router ID. Now S0, E0, S1, these are the physical interfaces. And if there is no logical loopback address or no manually address entered there, right? So in that particular case, highest physical address is considered as the router ID. So that is some of the name also of your router. So here out of this 1, 2, and this 3, which is the highest router physical address? 202.15.32.2. So this router will be treated as the router ID for further communication. Though the traffic may come from any direction, this will be considered the router ID, right? Then see here, when we start X start state, you know the concept of router ID now. Now here, what will happen for router, say this A and B, as per our discussion. This is the IP address 5.1 was 16.5.3. This is the IP address of router B. Now here in the X start state, router A will send as a database directory packet to the B, like I will start exchange because I have router ID 170.16.5.1. This router A will set router B, but router B reply in the BD packet like no, I will start exchange because I have a higher router ID. So just check here, out of this 170.16.5.1 and 170.16.5.3. there is no logical loopback IP address, right? Only physical addresses are there, this and this on this interface E0. So out of these two, which is the highest physical IP address? This 170.16.5.3. So router B has the right to start the communication. So in the X start state, it is decided between the routers that who will going to start the message exchange. Only that thing is decided. Actual message exchange is not possible, right? Only who will going to send the message first, that is decided in the X start state. Now in the exchange state, now it is decided that B will start the sending the message because it's a higher IP address. So in the exchange state, this all the information related to the networks is shared to the this particular router, right? That means here is a summary of say links. LSDB means link state database. So router B is sends the link state database summary to the router A, right? When you send that particular link state summary to the router A, so router A will say it will update that particular information, and then router B will also send some LSDB information to the router B. So that is happening in the exchange state. So in the exchange state we already explained. In the exchange state, say actual transmission is happening in the exchange state. The exchange summary of their own link state database or link state database, right? That is the link state database is sent. So here router B is sent first and then the router A, because B is having higher IP address, so it is going to send that particular information to router A. Now next state is the loading state, and after that you are having the full state, right? As far as loading state is concerned, in this particular stage, router A and B compares its own database with the received information from the neighbor. That means what happened here, actually see in the loading state. What is that? Yes, in the loading state, actually after the exchange of this LSDB, is that this you are exchanging this LSDB information. That means some table is exchanged with A is exchanged some information table with B, right? Then in the loading stage, what happened here in the loading stage, router A is having its own table along with the table or a table of information received from router B. So router A compares its own tables entry with the information received from the router B. If there is something different than its own entry, that means if we find some new entry, like say for example, now here say router is saying I need the complete entry of this 170.16.6.0 network. That means router A finds that there is new entry that I received from router B also. Router B, that is this 170.16.6.0. So this router will say I need a complete entry of this. The router B reply in the link state unit as a packet that here is the complete entry or information about this 170.16.6.0. Then router A will update that particular information, right? That means router's own information now is completely get matched with the whatever information received from that particular B. There is no new entry now. Same process is again happen to with the B. That means B is checking its own table on that particular information with routing information with the table or information received from the router A. If there is some new network, it will also say I need a complete entry of this particular new network. A will send that particular information, right? And then again it will say LSU. That means B will acknowledge that particular information, and then that means both the in this particular case you are having the you are updating and comparing both the table at each router. That is happening the loading stage, as I explained to you, right? Now next and last stage is the full state. Now here both routers have the same synchronous database post on this database. It will be going to calculate the base route using this particular formula. Now and they're writing the base route in the routing table, and based on this forwarding is happening in the full state. So in the full state here, then in the full state, the next is this full state, all both the routers here A and B having the same synchronized database entry at their level, and they will going to find the base route from it, and that particular base route then they are also calculating some cost value, and then that particular base route based on the cost value they will finalize the base route, and that particular base route will be exchanged with another suppose that A is interacting with some D routers with that particular, and D is a neighbor, so it will going to exchange that base route with the D along with that means that particular entry is also exchanged with the D router. Now here one thing you have to notice, or one thing you have to learn in this particular case is that is about OSF table, right? What sort of OSF tables you are having here? So you are having neighbor table, right? So that is also called as adjacency table, contains list of directly connected neighbors. This neighbor table entries is same as that of EIGRP, and you can use this command to check it. Now routing table is also same as that of EIGRP, but there is a difference in the database table, because here in OSF this is a database table, but in case of EIGRP that is a topology table. What is the difference here, right? So difference is that here in this particular database table, it is defined as a linked state database table. Now this database table contains information about all possible route to the networks within that particular area. Here in this particular database table, suppose I will explain you this particular concept of database. What is the distinguishing factor here? Now, whenever in the loading state you are, you can say that in the sixth state loading stage, you are taking the base route information with each other, right? So in that particular state, what happens? This I will explain to you. Last state in the database table. Now here, suppose you are having, this is first router, this is second router, suppose this is third router, and this is fourth router. So name of these routers are like this is router A, this is router B, this is router C, and this is router suppose D. Now and they are linked something like this, okay, right? So and I want to send some packet to the router D, right? Router D is not a direct member of this A, a neighbor of the A, but B and C are neighbor of A. So router A can send packet to router D through B and through C. That is possible. But here, suppose you are having few, say another route, something like that. 4 or 5 routes are there. Suppose this 8 route hai, right? Then from here to here you can go. Then you are having suppose one more router here, and then you are going from here. Here suppose you are having one more router and you are going to D. That means from router B there are 1, 2 and 3 routes to reach to router D, and from router C there are 2 routes to reach to the router D. From C to D 2 routes are there, right? Now in OSPF, whenever in the loading state the B will share its information, linked state database information with A, LSDB with A. It will share all the 3 routes with the A. That means it will update all its 3 routes to A. Similarly, C will also update all its 2 routes with A in OSPF. But in the previous assignment in the AIGRP, remember that out of these 3 routes, B will only exchange the best route with A. And out of these 2, only one single best route will be exchanged to A in case of EIGRP. But in OSPF, as it's a linked state protocol, here it is exchanging all the information with A. Same first. That means all 3 entries are get copied to A, and here also all 2. That means total 5 entries are there in the A, right? Then out of this 3 plus 2 plus its own entries, other entries of this A, it will going to calculate the cost, and then out of this the cost which is less is treated as the base route, and that particular again information it will say that this is the base route. Suppose another, say some router is there, right? Then and he is interacting over here. So this particular A will also exchange 3 plus 2 plus suppose some another routes are there that exchange with this particular router. So this is the concept. Got? Now because of this, whatever problem, that means every time all the tables, all the routes are gets updated to A or other routers in this case. So there sometimes some few routers may running out of the memory. That problem may occur. So solution to this is nothing but the concept of the area. You need to introduce the concept of area, right? So 3 tables I explained: neighbor table, database table, and routing table. Routing table contains list of best paths to each destination. Now a database table, how it is different than AIGRP's topology that I already explained. Then next is concept of areas. I have told you whenever some routers are running out of memory because of more information at their site, so you are supposed to logically group the routers together, right? So concept of OSPF area. So you know that all router must maintain same database in OSPF. So any change impact all the router in OSPF. So area is nothing logical grouping of routers. Sometimes routers running out of memory, so they may go down. So if this happened, they are unable to communicate. So to avoid this, we use the concept of areas. Now see here. Suppose 6 routers are here. 1 router is here, and 3 are area border routers. So by default, area 0 is there. So that is this area. that you are supposed to have. And then you have group 6 router in area 1, 6 router in area 2, and 6 router in area 3. And the 3 routers you have placed between the say area 01, between area 02, and between area 03 respectively. These routers are called as area border routers, right? They contain the information about the area and their interfaces. And here this 6 router falls under this area 1. Now here what actually happens, whenever there is any change or a link failure, link update for this particular router, it will update that information to rest of these 5 routers only in the area 1. It will not going to update to each and every router in that particular areas, right? Then ABR will have that responsibility to just keep that particular information with it. So that's why here we are decreasing the size of the database, right? And this will going to you can say that whatever the routers are there, they are not going to running out of the memory. So that is the concept of area. You can also represent area like this, or like this also areas. This is the backbone or internal backbone area 0. This is area 1. This is area 2 with their internal routers. Right, so your OSPF areas are like logical grouping of routers. OSPF provides hierarchical network design in multiple different areas. Some rules are there for OSPF areas, like OSPF areas must have one area called as area 0, that is backbone area. By default, area 0 is there. So here we're going to implement single area OSPF, right? Only single area 0, all routers we keep in the area 0, and that we will implement. As a homework or curiosity, you can also go for multi-area OSPF configuration. It's up to you. Right? Then all the areas must connect to the area 0. All at least one area border routers are there. The interfaces of both routers facing must be in the same area. Right? Advantages of OSPF, that is no count limitations is there. That's why advantage loop free, open standard, faster conversion. Limitations of OSPF like consume more CPU resources because they are updating all the routes with the neighboring routers. So consumption of resources are more in this particular case. Complex designs only supports equal cost load balancing. Unequal cost load balancing is not supporting. Okay, now we'll see how to implement this particular case. We'll see single area configuration of OSPF. So this particular network design we're going to consider here. So we'll open the packet tracer. Now here I will take the scenario. I'll open it. So this scenario already we have designed. Just I will remove that particular version of protocol, and from scratch I will explain to you. Okay, now I will start stepwise implementation of this, right? So such type of network design you have to create. Click here. You are supposed to enter the IP configuration here. So it is 1.192.1.2 is already entered. Its gateway is here. I have entered this. This is there. Then for this space is 192.168.0 network. So for this desktop IP configuration is there. IP address of the PC and the gateway. Similar for this PC, 192.168.2.2 is there. Then when you click to the router, go to configuration and the fast. Now here there are two serial links, this and this. Just go to this above serial links here. What you are seeing is a serial link 2/0 and serial 2/0 interface between the router 0 and router 2. Router 0 and router 2, right? This is network 10.0.0.2. So towards this side 10.0.0.1 IP address, and here you are having serial 2.0 IP address is 10.0.0.2. Now here when you click here for the link between router 0 and router 1 serial link, so it's a serial 3/0 towards router 0 and serial 2/0 towards router 1, and it's a 20.0.0.0 networks and their IP address at the interface. And when you come here, it's a serial 3/0 and serial 3/0 network. It's and the network is 30.0.0.0 and their IP address on the interfaces. So same, if you click here and config, go to fast Ethernet 0/0. See here for the router 0, 1.1 gateway and port is on, correct. Then just see serial 2/0 interface is 10.0.0.1, that is 10.0.0.1 is here. As it's clock, we are setting the clock and making it on. And this router, when you click, sorry, for this again one more interface, serial 3/0 is there. That means this serial 3/0, this interface, right? So for this particular serial 3/0 interface, 20.0.0, this you have to enter and make the port on. Same thing you have to repeat for this router. Just check fast Ethernet 0 address, serial 2/0 address, and serial 3/0 address we have entered. Next for this, go to configuration, check the fast Ethernet address for router, this particular router 1 के लिए भी आप करके देख सकते हो. This one is there, serial 2/0 address is there, and serial 3/0 address enter, correct. Now we have to configure OSPF on this router 0, 1 and 2 for this network design in short. So click on the router 0, right, and go to this command line, and just here just type router. Here just type router and OSPF. Now I just wanted to tell you something, that means how to configure that particular OSPF. Now this network is designed. I'm clicking on router 0. Now what command you have to enter? You have to enter router OSPF process ID. Here process ID is in between 1265535. Now for this OSPF protocol, the process ID can be same or different, but in case of EIGRP, we have used the same ASN number as autonomous system number. That means if you are using 1, it should be 1 for all EIGRP in that particular router. But here you can use same or different between 1265535, right? And then you, after that command, you are entering this router 0 and this command, right? Network, you are advertising the network or different networks on a given router. So network ID you are entering, and then you are entering wildcard mask for that particular network IP address. And after that area ID, by default area ID will be 0 because we are using single configuration area OSPF configuration. Now how to find a wildcard mask? Now wildcard mask is for global subnet mask minus subnet mask. So for example, 192.168.1.0, right? So for this network, what is the wildcard mask? Now global subnet mask is 255.255.255.255. What is the subnet mask for this 192.168.1.0? That is, now as 192.168.1.0 class is network, the /24 is there. That means 3 bits active. That means 255.255.255.0. that is the subnet marks for this. आप फास्ट इथरनेट ऑफ 0/0 में जाके भी आप चेक कर सकते हो, इट्स नॉट बिग डील, ठीक है. बट द थ्योरी बता रहा हूँ कि कैसे आता है कि वंस क्लास सी के लिए ये सबनेट मास्क होता है इन जनरल. क्लास ए बी यू कैन आइडेंटिफाई, और /24 हो या फिर 8/62, अकॉर्डिंगली यू कैन फाइंड आउट द सबनेट मास्क. Now these two things are there. You have to subtract subnet mask from this. That means here I can say you can minus subnet mask from J. So 255 minus 255 is 0, 255 minus 255 is 0, 255 minus 255 is 0, and 255 minus 0 is 255. So wildcard mask for this particular 192.168.1.0 is 0.0.0.255, right? So that thing you have to enter. So when you click on router 0, you are entering this particular command, router OSPF 1, right? And then you are entering the network 1.0 and their subnet marks, sorry, wildcard marks, and area is 0 by default. Then for another 10.0.0, so for this their Ethernet their subnet wildcard mask is this 0.255.255.255 आएगा, right? So like this. So OSPF से process 1, right? OSPF router 0. I'm clicking on router 0, OSPF phase 1. Then I'm seeing network, right? So sorry, say network 192.168 dot say 1.0 first, and this wildcard mask will be 0.0.0.255 and area is 0, correct? The next network is nothing but that 10 dot, right? देखो आप means ऐसा कुछ नहीं, यहाँ पे देखो आप for router 0 I'm entering now. For this router 0 192.161.0 ये नेटवर्क एडवर्टाइज किया ना हमको 10.0.0.10.0.0 दैट मींस दिस नेटवर्क और दिस नेटवर्क को भी एडवर्टाइज करना है. सो दैट्स व्हाई आई एम राइटिंग 10.0.0.0 and the wildcard mask will be here, that is 10.0. Wildcard mask will be 0.0.0.255. Area will be 0. You can also cross check it. That means see here in this our 10.0.0 and wildcard mask will be 0.255.255. Sorry, 0.255.255. That is the wildcard mask. 255.255.255, correct, and then enter, right? Then same for 20.0 networks, right? Enter. That's it. Router 0 का हमने config किया OSPF. Now you can check that also whether show protocols करके. If you go exit sh protocols, right, you will find that. See here, where is that command? SHIP show protocol, SHIP show IP protocols, and say enter. Yes, it is showing. That means okay, इसमें से where OSPF हटा ही नहीं, शायद हमने सेव नहीं की थी सेटिंग. ओके show router से conft no router AIGRP इस पे ऑलरेडी राउटर AIGRP 100, ठीक है. शो IP protocols, here OSPF 1 is there, correct? OSPF 1 is visible to you with these IP addresses, correct. Done. Then here again, just first of all enter exit no IP no router. I will remove AIGRP if it is there. Router no router AIGRP करके लेते हैं. No router AIGRP 100, right? Okay, now we'll configure our OSPF router OSPF 1, right? Then we'll say network 192.168 dot what is that 3.0 with vertical mask कितना आएगा उसका 0.0.0.255 with area 0. Enter. Then what you have to advertise? You have to advertise the network now. 20 का नेटवर्क मॉस पे ऐड करना है हमें, राइट. राउटर 0 देख सकते हैं आप, ऐसा कुछ नहीं. 20.0.0.0 and its IP address will be 0.255 dot and this area. You can cross check also here. When you click on the router 1, for router 1 it's see 3.0 and then 20 का हम तो 0.255 पे करते हैं, ठीक है. then you see just say enter 20 और उसका और एक नेटवर्क है 30 का है, राइट. यहाँ देखो ना 30 का है, अगर कुछ क्वेरी हो माइंड में तो देखो. इस राउटर के लिए मैंने पहले 192.168.3.0 का नेटवर्क एंटर किया 3.0 then 20.0 अभी किया, then I have to enter this 30 का अभी नेटवर्क that you have to advertise on that particular router 1. So here just say 30 कर देते हैं सिर्फ. enter, इसे exit, show IP protocols. So it's showing you OSPF, correct? So your output coming with this network. Then click on router 2. अब इस router 2 के लिए हमें कौन से एडवर्टाइज करने हैं 10, 30 and 192.2.0, right? So I will start with this command enable router. First of all इसे प्रोटोकॉल है show IP से EIG show IP protocols करके देख लेते हैं protocols. तो ERGRP तो I will remove it. No router EIGRP से 100. I will remove. Now show I will show IP protocols. You can check it now. EIGRP 100 is there. So sorry, I had to conft में जाके remove करना पड़ा. conft no router EIGRP 100. Enter. Exit. And now check show IP protocols. So here no router IP protocols. Okay. Show IP protocols. No protocols. It will router take some time for updation, so no IP protocols. Now I will configure this OSPF instead of EIGRP. Router OSPF with process ID 1, then network 192.168. This 2.0 with wildcard mask at as 0.0.0 sorry as 0.0.0.255 and area 0. Enter. Next what you have to enter is 10.0.0.0 with wildcard mask for its 0.255.255.255 with area 0, correct. Next same 30 को मुझे एडवर्टाइज करना है राउटर 2 पे. So just say 30 here. Enter. Exit and just say show IP protocols. So it will showing you the protocols. Now we'll check the output one by one. Now when you click to this particular router and I will check its neighbors, click करो, then say here just say show IP OSPF and neighbors any IGHBORS neighbors. Say enter. Sorry, it will show you the neighbors. Now see here what thing you have to output you have to check. It's a full state में आपका पूरा configuration हो चुका है. That's full state, right? 192.168.2.1 for this neighboring router ID and 192.168.1.1. So these are the two say IPs for this particular router 1. Here we are checking, right? And for this ISP's OSF neighbor, then if you click on this, say for example, and if you write show IP, show IP OSPF any GHBURS neighbor enter. So 1.1 and 3.1 it is showing you that, right? And that means for this 1.1 and 3.1 they are the neighbors on that particular interfaces, right? So when you first of all one more thing you can do, setting में जाके save करो whatever आपने किया उसको setting, go to the settings of each router and save it. That's important. Config and then settings and save in the NVRAM as I told. And again when you go to this particular CLI command of router 1, just say show OSPF IP, right? So it will again show you the neighbors for it. Then config check fast Ethernet family Diana fast Ethernet 3.1 serial pay this address and serial to be this address, correct? Then go to here and just say CLI page, okay, show IP OSPF any IGHP database right? So it will show you the entries there, right? And with OSPF router ID that you are supposed to consider. Now for this router 0, this database is like they are supposed to consider that particular database. So here 1.1 is there for this, and this 10 dot and 20 dot. So out of these three, this 192.168.1.2 is the highest. So that's why it's a process ID is there. Then it's process ID is 1 and it's a router ID, highest physical address. So highest physical address will be treated as the considered as the router ID, right? Then you can execute another command like say I'm ping say this particular machine, from the router 0. Ping 192.168.2.2, enter. It should show you the success, and just say trace trace route 192.168.2.2 and say enter. So it's saving in the route like this. That means from this router, if you want to reach to this particular machine, so there are two routes, this and say this. So this router will follow this. That means how it will show you that. Just check here. First of all, from here the packet will go to the 10.0.0.2. That means this router, right? For this particular router. Then the packet will reach to the 192.168.2.2, right? So that base route is selected. Then as far as this when you click here, say on this router and say show, this is the final output. I mean, so this route again you can show IP and say if you say our possible route to destinations like this. So here your administrative distance 110 and cost is there. If you vary bandwidth, the cost will vary, right? So here if you observe that direct connection of this router 0 with this particular 10, direct connection to 20 and to 30th network, that means this network the connection is through 20.0.0 and via this 10.0.0.2 that is shown here, right? A 30th network कैसे connect हुआ है, and as we are using OSPF learning here, so it will finding the routes like the to 192.168.20 networks. So that is via 10.0.0.2 serial to /0 with this, and 192.163.0 that is via 20.0.03 networks with their cost. Here also with their cost it is showing you the values, right? Sometimes suppose if you go to conf and say configuration, say here if you want to change the bandwidth here, suppose 1.5 का मैं suppose 600 कर देता हूँ suppose on serial 3/0 in conf t, go to interface serial 3/0, enter, and if you say bandwidth and we say 512 and enter. Now if if you say exit, and if you say show IP route, enter. So here, see, we have changed the bandwidth of this particular serial route. Right here, serial 3/0 जो था यहाँ पे this का 3/0 for this network, we have changed the bandwidth of 1562, right, from some another value. Now see here, the change is there. अब यहाँ से 102.976 था ना, because of bandwidth change, देखो यहाँ पे कॉस्ट 72 आ गई, यहाँ पे भी 30.0 की कॉस्ट क्या थी, देखो अभी यहाँ पे रूट भी आपका चेंज होगा, ये वैल्यू भी आपकी, it is coming 976. Now for 2.0 3.0 initially values क्या थे आपकी 782, but when you vary the bandwidth, now this is the minimum, this is the best part, right, and this is still having the, sorry, this is now the best part that we are supposed to consider, because cost is 196 and here it is 72, so the second part will be the best part in this particular case. So in this particular fashion you can analyze the entire thing. And if now from the router 0, we are in the router 0, now if you ping say 192.168, let's see what, because metric calculation by default router से हो जाता है, and if you say trace route 192.168.2.2 and say enter, see here it will giving the still it is follow that particular base route, right, for that particular reaching to the 19 this particular route, right. So this is the way you can work out this particular entire process.